Final exam review package 2. Do as many problems as we can. This one is literal equations, and it's literally finding the letter that they ask you to find. This is the symbol pi. A letter or a symbol. It could be a Greek letter, it could be Roman letter, it could be Hebrew, who knows? But whatever it is they ask you to find, you got to find it. So in this case, you're solving for pi. What do you do with this to find pi?
Divide out the pi.
Divide out our square.
No, you don't divide the pi. The pi is fixed. You leave whatever you're searching for, you don't move it.
I thought it said 4
you-
pi. Oh, right.
You divide out everything else that's there. In this case, it's r squared.
I misread it.
No problem. Pi equals a over r squared. And that's it. That's it. You're done. Real simple.
I remember these now.
Yeah, you remember these now. Number 2, a equals a plus b plus c all over 3. And you're solving it, solve for c. All right, now what are we not going to move?
C.
We're not going to move the c, but what do we have to get rid of? Oh, fractions, not those again. How do we get rid of fractions? A quick and easy way? Let's get serious about getting rid of these things, okay? Yeah.
You multiply.
By what?
By when you multiply by 3.
Yes. You multiply by 3. Why? Because that's the needle area. What's the thing we want out? The denominator is the thing that makes it a fraction, and whatever it is down there, we want to multiply by the LCM. It's 3 because it cancels, and it's 1 over 1. 1 times anything is anything. So 3a equals a plus b plus c, and man, oh man, a ray of sunshine just came in on this problem. It looks so much easier without there being a denominator. So right now we just want to fix c and get these two things out of the way. What do we have to do to bring it to the other side? What?
Divide by 3.
No, we want it. This is fine where it is. We want this alone. So what?
A plus b divided.
Not divide.
Subtract it.
Subtract it.
Oh.
Subtract a. I'm going to do them one by one. See that they're separate. This is 3 big A minus small a equals, so these cancel, boom, plus b plus c. Now we just go ahead and subtract b. And I mean, if you're advanced enough, you could do that in one swell swoop. But, you know, I want to make sure that we show this real clearly. Everybody knows. So 3 big A minus b equals c, and that's it. Why did we subtract here and divide up here? Great question. Can anybody see the difference? What's the difference? This is pi r squared. What is the relation of r squared to pi? Is it added to it or subtracted from it, or is it divided, or what? It's multiplied. It's stuck on there. It's really, really close. You can't get it off. You've got to take some major measure. You've got to take some major measures. Major measures. Say that 5 times.
Major measure.
Oh, it's a killer. Major measures. Major measures. Hello. This is a. It's not a times c. Yeah, exactly. See the difference? It's b. There you go. That's why you subtract. Okay, gotcha. Okay.
Me either.
Okay. What do we do? It's a fraction. How do we get rid of it, Caroline?
You multiply by the AB.
Multiply by c.
C. That's
Why would
what
you multiply by
You
a?
want to get the C.
No. We multiply whatever it is on the bottom. We want to get rid of it. That's simple as that. Always just get rid of the fraction by multiplying it by the denominator. Okay. So don't overthink it. It's CP equals AB. Say that 5 times. CP equals AB.
CP equals AB. CP AB.
Okay. No. Yeah. Okay. For C, now we're almost done. Just divide by P and we're done. Okay.
Why
So
P?
C, because P is
we
in the
wanna
way of
get-
C.
Because we want to get c by itself.
We want to get it by itself. The thing is, we had to move it only because it's in the bottom of a fraction. It's the only time you move it. Is
C
when
equals
it's,
cab.
yeah. Okay. Good. Now, a harder one. This is the hardest of these 4. E equals mc squared for C. So now we're going for C. Well, we still don't want to move the C squared around. But what would we do first? What do you think?
We would.
Well, that wouldn't be the first thing you do.
Would we divide by the m?
Yes. Divide by m, and we get looking a lot like m. E over m equals c squared. Now, normally we'd be done, except for they asked for c, not c squared. So, a little bit strange.
Divided by MC.
Divide by mc. Okay.
Oh, do we? No, do we
Nice
divide
idea.
by
Somebody in
c?
the last, if we divide by c or MC, it's a nice idea. The problem is, if we divide by c, we're going to get c down here. It's like typically you can't get rid of the thing. You know, so we don't want to make things more complicated. So what if we have c on this side, we can't have it over here. So how do you get the square of c down to
Square
the
root.
right. That's exactly right. You take the square root of this side, and in math, whenever you take one side, what do you have to do to the other? Hey, you got to do both sides. It's equal. It's justice. It's a subject with complete justice. Whatever you do from one side, you got to do the other. So what's the square root of c squared, guys? C equals the square root of e over m, which is great, except for one thing.
You need
we
to
done?
do, no.
Uh-oh.
You have to do, yeah.
Why are we not done, guys?
Because you can't have,
Have a
you can't
radical
leave it as a
denominator.
fact.
You can't have a radical in the denominator, so what do? We rationalize the denominator. How do we do it?
Multiply everything by
M.
that root over that root.
Yes,
by
by the root of
m.
m over the root of m, okay? The root of m over the root of m, which is actually just 1. Isn't it? The root of m over the root of m is actually just 1.
It is.
Just decided to take on a different form. That
Yeah.
tricky one, I'm telling you.
E
King
m
of all
over
numbers
m.
can do just about anything he wants.
You get square root em over m.
And guess what? You're done.
So c equals
Square root em,
em over
What
m.
do you think, Em? Solve for y. It's xy squared equals 1/2 z. All right, what do we do first? We
Divide. Times it by 2.
Multiply.
yes, get rid of the fraction, for goodness sake. And let's get that. It's going to be 2xy squared equals. Too bad we weren't just trying to get z. But we're not. We're trying to get y squared. So what do we do over here to get rid of y?
Divide by 2x.
Divide by 2x. We get y squared equals z over 2x. Okay? And then, again, we have to take the square root of both sides, and we get y equals square root of z over the square root of 2x. Are we done?
No.
Not quite.
Never done.
Rationalize the denominator by multiplying by what?
2x over 2x.
The root of 2x
Yeah.
over the root of 2x, which is actually just 1. So we get 2zx over 2x. And
That's
now,
all she wrote.
that's all she wrote. There you go. We're done.
But wouldn't it be xz?
Okay, from chapter 5, this is polynomials. Some people got confused and they thought they should factor this. But, you know, I know why they
Well, you
thought
should
it.
always check to see if you can factor it first.
Well, no, well, yes and no. In this case, this is multiplying polynomials. So you're doing the superfoil method, okay?
Distribution.
And I like to move
Oh my
this
God.
over, 3x
Serious?
minus 2. I'm just going to commute this, okay? All right? 3x minus 2 onto 4x squared minus 5x plus 1. All right? And superfoil. 1, 2, 3. And that's going to be 3x times 4x squared. And then 3x times negative 5x. And 3x times 1. And then down here we go minus 2 onto there, minus 2 onto there. We're superfoiling to negative 2. And we get negative 2 onto negative 2 onto 4x squared. We get negative 2 onto negative 5x. Okay? Negative 2 onto negative 5x. And we get negative 2. Negative 2 times 1.
I
And
got my answer.
now we've got, to finish this off, we're just going to collect like terms. We get 12x cubed. We've got negative 15x squared. Okay, so it's negative 15x squared, and this is negative 8x squared. And this over here is going to be 3x, and this is going to be 10x. And this is minus 2. We're almost there. We're just collecting like terms. And we've got 12x cubed minus 23x squared plus 13x minus 2, and we're done. That's just a lot of collecting like terms, multiplying things out, and stuff like that.